Hello everyone, welcome back. In our today's session, we will have discussion about public IP address and private IP address. So first of all, we will try to understand what is public IP address. Public IP addresses are routable on internet. Internet is a public network, okay? That's why we call to these addresses public IP address. So they are routable on the internet, and they only used for the internet in devices. For example, you want to make available your server, your device on the internet, so then you need to have a public IP address. In public IP address, you will have it from the ISPs, okay, internet service providers. They provide it in based on a monthly charges. Okay, let's have a discussion about the complete ranges of the IP addresses based on our previous lecture understanding, as we covered over there class A, B, and C. Because the main reason why we are going to revise some previous lecture things to understand why we were required to have private IP addresses, okay? Because there was a problem with the IP address, and then the problem of limitation, and the problem of limitation gets solved with the help of private IP address. But we need to understand this how. As we know that the usable IP address in the class and the version 4 is class A, class B, and class C. The range of these classes starts from 0 to 223.x.x.x. Okay, this is the total range of class A, B, and C, including the reserve addresses, including all addresses. Okay, and let's find out the total number of these addresses available in the class A. Okay, total IP addresses. In order to find the total number of addresses, we require to use this formula: 224 multiply by 256 multiply by 256 multiply by 256. This 224 comes from here, okay? From 0 to 223, it's equal to 224. From 0 to 255, you know that the start of this is 0 and the end is 255, so this is equal to 256. Okay, so we have 3 octets: 256, 256, 256. The total number is equal to 3 billion 7,058 lakh 96,384. So this is the total number of addresses available in class A, B, and C. Now let's suppose all of them are usable addresses, and for example we have only single network, internet mean public network. Okay, according to a current estimate, the total number of active users, okay, active connected devices, not about users, connected devices, okay, is almost 30 billion. It's what? It's 30 billions, okay? And here, what is the available number of addresses here? Is 3 billion something. So there is a huge difference. And this by default it had limitation problem, okay? And this limitation problem was expected, and the at that time the researchers were expecting this problem, that looking to the internet growth, that in the near future we will be facing lack of IP addresses. So that's why they were thinking about a solution, and the solution was, and they find a solution. The solution was IP reuse. This was a solution, IP reuse. What is the meaning of IP reuse? IP reuse means using a duplicate in a same address again and again, or at the same time by multiple in devices. Okay, by multiple device. This is the concept of IP reuse. So now, how to make possible the IP reuse? For to make it possible, we were required to divide the internet okay, so we did that. We did this division, and after the division we had two types of network: public address networks and private networks. So private networks mean organization networks. Organization networks. Isolated from internet. Fully isolated, but only connected with the help of proxy. Okay, isolated means nothing is routable from here over the internet. Like before, we had a single network. We were required, let's suppose the 30 billion users need each unique address, but the available address is what, 3 billion. It is not possible to assign from this 3 billion range IP addresses to each. Okay, so there was a problem solution get introduced, that was IP reuse. For to make that possible, we divide the network in public and private. Okay, so now what is private network? It's organization network, like your organization network, your home network, my home network, okay, so on, and they are isolated from the internet. So after these divisions, the world had two types of network. One is called internet, and another is called what? Organization networks. Let's suppose it represent organization networks. Okay, it means this one is public and these are private. Okay, so the private networks support what? IP reuse. So for example, this private organization A network is B and C. Let's suppose it's using class A private 10.x.x.x. The B can use the same address 10.x.x.x. The C can use the same network 10.x.x. No problem, because A and B both are isolated network. Okay, so there is no duplicate issue. There will be no that issue. Okay, if they will become the part of one network, then they cannot use one single address. For example, let's suppose here we have a computer. This computer can use 0.0.1, and here we have a computer. This computer can use the same. See, network is same here, the host part is same here, but no problem because they both are what? Because both are isolated. They are not part of one network physically. Okay, so that's why no problem, and that's why the IP reuse become possible. And when we can use one address for the unlimited number of computers and networks, so that's why there will be no more the limitation problem. Okay, and this 30 billions is divided. Okay, some of them remain part of the public network, and some of them is shifted to private network. Like your mobile phone, your laptop is part of internet, but actually it is connected where? Connected with a private network. Okay, and your private network with the public network is communicating with the help of proxy or with the help of NAT server. In internet have no idea who is here. Okay, so this was the reason that why we were required to have private IP addresses. The main reasons was the limitation problem, okay, or the efficiency problem. Now let's discuss the ranges of private IP addresses in each class. In each class. Class A 10.x.x.x. The start, the end. 10 dot. Okay, this x mean that the starting is 0 0 0. 10 dot 255 255 dot 255. Okay, x mean both. Okay, 0 to up to this. Class B 172 dot 16 dot x dot x 172 dot 31 dot x dot x. In class C 192 dot 16 dot 0 dot x 192 16 255 dot x. Okay, keep in your mind x is the host part. Okay, and x is the host part. Okay, and this is the network part. Okay, class B have total number of 16 networks for the private. It have single network. Class A have a single network. Net class. Okay, let me write it properly. Class N number of networks. Class A have one network. Class B have 16 networks. And class C have 256 networks for private users. One mean only the 10 is a network. Okay, here is 16 mean start from 16 up to 31. Okay, and 256 means start from 0 to 255. So this is the number of private networks in each class, and mostly we use for small organization or small networks, we prefer class C because the total number of host is here per class per network is 256. Okay, why we prefer it for the small networks? To decrease the wastage of IP addressing, to avoid the subnetting headache. Okay, class B, when you required 256 multiplied by 256 means 65,000 and something host addresses, then you require to choose from the class B. If you need more than 65,000, then you can go for class A. Okay, if for example, if you need this much addresses based on a classful approach, then you will pick these classes without subnetting. So this was the range of private IP addresses, okay, in each class. Okay, dear students. So the once again come back to the public addresses. Remember, public addresses is only routable on the internet, okay, not routable on the local networks. So it means that the internet is available on the private IP addresses. Okay, for example, you want to be part of this. For example, you want to be accessed. Let's suppose this is your computer. You want to be accessed from here directly. Then this PC need what? This PC need public address, public IP address, because at the mid the routers can find out this public IP address. Now both are part of one network, that is what? Internet. So it's routable. If for example, if this PC want to be accessible, so it's also need public IP address, so then it can be also accessible. Internet will be available on these public IP addresses. But let's suppose here is your private network, and here you have many computers. Remember, none of them is routable, their addresses, for example 10.0.0.1. Okay, it is not routable on the internet. Why? Because it's private. But internet is not also available on this address. But for example, you want to use internet on this, or you want to have internet on this address, then at the mid here you need something called NAT. Okay, you need a server called NAT server. Sometimes we call it proxy server. This will do what? This will do network address translation. Network address translation. So this will do the translation, like for example, a request is going to the internet. So the request, for example, from here, and remember this net have two interfaces, okay? One interface is connected with the public, one interface is connected with the private. Now a computer want to access any of this server, let's suppose. So their request will come where? Their request will come to this LAN interface. The LAN interface here, what's running? NAT server. They will translate it to the WAN interface, and then the WAN interface will interact it with the destination computer, and response will come back to this WAN interface, and WAN interface will again translate it to the LAN interface, and LAN interface will reply back to this computer. Okay, so it acts as a proxy. Act as a proxy. Okay, this public have no idea that he is communicating with this private. They will assume that he is communicating with what? With this WAN interface. Okay, and remember dears, the WAN interface must have a public IP address. So LAN interface and WAN interface. LAN interface will have what? Private IP address. And WAN interface will have what? Public IP address. So if you will have a single public IP address on your WAN, so if you will have here thousands of IP addresses, no problem. This NAT will do translation. The request will come from the private to the NAT. NAT will forward it to the public, and whenever the response come to the public, they will give it back to NAT, and the NAT will translate it to the private. Okay, dear students, so this was a brief explanation about the public and private IP address, and in case you have any question, any confusion, you can ask in the comment section, okay, and I will definitely reply. Okay guys, so this was about, yeah, In our next lecture, we will start subnetting. So see you in the next lecture.